Welcome everybody on Zoom, welcome everybody in the lecture hall, welcome everybody from the future. Today we are continuing on the syntax of semi-structured data, denormalized data. We will see that this is all about trees really, because collections of trees are basically denormalized tables, right? So this is the idea of what happens. We basically had the good old relational database systems from the 1970s. And then we noticed that as you actually collect real world data, especially in log and created over multiple years, the data is actually messy, right? See, this is the ideal vision of the world where everything fits in a table. And in the real world, it doesn't. So you might have extra attributes in some records. You might have missing values. You might have invalid values in the sense that in the same column, you have multiple types. You might have nested values. In that case, I drew tables, but it can be even messier than that. You can put anything structured, really. And so we call it nested and heterogeneous, as opposed to flat and homogeneous. We will see that these two are orthogonal, right? You can have nested homogeneous that exists as well, and you can have flat and homogeneous and heterogeneous as well. All right, so let's dive into JSON. Who already knows JSON? Okay, who doesn't know JSON yet? Oh, that's going to be quick. Okay, then I can do it quick then. All right, it's actually quite easy, because I'm going to present it in terms of building blocks. But remember that we are talking about text right now, right? I have a text file, and I want to say yes or no, it's valid JSON. So I'm showing to you what I want to see in that text file so that it actually successfully parses as JSON. So the first thing that you will see are strings, always double quoted, right? Shouldn't surprise you. It's like in many programming languages. In fact, the J in JSON, JS comes from JavaScript, right? That's JavaScript object notation. So this is a string, and the string is a well-formed JSON value. And you can also escape with the backslash. If you have new lines, then backslash n is recognized. And with backslash u, that gives you the magical power of adding emojis and all the Unicode codes that you can think of, the other alphabets. In there, right? And this, of course, is going to be passed into something in memory that will have, of course, escaped these, right? So you have to resolve these in order to get the actual characters in the string, right? So always remember there is the physical layer. Well, this is the sequence of characters you have in the text file. But once it is parsed in memory, there's an F, an O, and then this is a single character, then BAR, and then this is a single character again, right? Once it's in memory. Okay, these are the strings. No single quotes. It has to be double quotes. Then you have numbers. So numbers are actually pretty generous in the sense that there is any precision. It's totally arbitrary length. So you have integers, of course, but you can also have decimal numbers using this decimal period. And you can also add a sign, of course, in front if you want it to be negative. And then this is the scientific notation, right? It means times 10 to the power of. And here it can be, of course, negative or positive. The plus is, of course, optional if it's positive. That shouldn't surprise you, right? Can you see well, by the way, the slides here? Even maybe we can slightly move it like this, make a bit of space. All right. So these are the numbers, and you can really have an arbitrary precision. If you want 100 digits, you can have 100 digits on either side of the decimal period. But the thing is, the limitations will depend on the library you are using, right? Because there's plenty of JSON libraries out there that allow you to parse these things. And it might be that some libraries will have limitations, that they will say, okay, if there is a number that has more than 200 digits, then we cannot parse it, right? But this is really library specific. But I assume that any library will at least offer a precision of 15 digits, which corresponds to a double. So I assume that you have at the very least the precision and the power of 10 interval of the double standard, i.e. 754. Okay. All right. And note that at that point, this is just syntax. There is no difference between integers or decimals or doubles or floats. We don't care at that point. This is just syntax. It's just a mathematical number, either as a sequence of decimal digits or with a power of 10, but there is no differentiation between any types. There's just numbers and that's it, right? Okay, now we have Booleans, true and false, without quotes, just true and false. These are called literals, right? And then we have the null literal that is representing the fact that we don't know the value. It can have a lot of different semantics, right? The null can be you don't know, can be you do not have the right to see it. Note that in JSON, an explicit null associated with a key is not the same as the absence of a key, right? So if you have the key doesn't appear, it's not the same as having the key associated with null. But I'll come back to that, right? So there is a difference. Some libraries might identify the two and consider them the same, but generally it's not the case. Okay, so these four, strings, numbers, booleans, nulls, you can learn it by heart. These are the four atomic values. These are the ones that you would allow in a flat relational tables as values, right? And then we have two kinds of structured values, objects and arrays. And you can really see them in terms of abstract data types, right? You remember that you have the actual implementations of the data types and then the abstract data types. An object is just a map, right? It's just a map from strings to any values. And that's recursive because, sorry, this one, to any values. So that's recursive because the values can be anything. The values can be strings, numbers, booleans, nulls, objects, arrays, and it just goes on like recursively, but still finite, of course, as I said yesterday. And again, this Q null, do you see the Q null? This is not the same as not having the Q key at all. This is not the same. There is really a semantic distinction between the two, in the sense that the application that uses the JSON library should be able to see the difference, whether it's a null or whether it's absence, right? And finally, we have arrays. Arrays, the abstract data type is, you remember what it's called, the abstract data type of that? It's a list, right? List, set, bag, maps, these are some of the abstract data types. So this is a list. It means that there is an order in the values that they are in there. The values can be, again, any of the six, strings, numbers, boolean, nulls, objects, arrays. It's fully recursive, finite again, right? So you can have an object in an array, in an array, in an object, in an object, in an array, and so on. So the order is important. There is really the first position, it's a number. The second position is a boolean, and so on. While in an object, the order of the keys is not important, but that shouldn't surprise you because we said it's a map, right? And you know that in a map, there is no specific order at the logical level between the keys. There might be a physical order. If you implement the map as a tree map, for example, you might have a physical order. Typically, a lot of systems keep the order in which you inserted and try to have something relatively stable. But on the logical models, the order of the keys doesn't matter, right? Okay, that's pretty much it. That's JSON. So now just to go a bit further and give you a few examples of what's well-formed and what's not well-formed. The first example here is not well-formed because the key must be a string, double quoted, always. That's an array, that's not possible, that's not a key. This is an integer, it has no quotes, a number more exactly. It's not a key, it cannot be, right? This here is well-formed, this is not well-formed. Okay, that would be an error for two different reasons. Any JSON library should normally reject that. Second, this on the top is not well-formed. And this is because we have twice the same key. Foo, that cannot be a map, right? A map, you really associate just once every element of the domain, right? So that we cannot accept. The second one is fine because there's the key foo and the key bar, and they are different. Note that it's a should in the recommendation in the RFC. It means that it's not technically enforced in the sense that everybody is obligated to do that. So you might find JSON libraries here and there that kind of won't complain if an object repeats. But the people who do that are playing a dangerous game in terms of interoperability because a lot of JSON libraries will reject these because you cannot build a map out of that, right? You would have to make something more complicated. So you probably heard as computer scientists, at least all of those of you who are computer scientists, that a should be treated as a must in the same way that a warning should be treated as an error, right? If you want to be really safe. So this is the spirit of it. And so in this course, we will treat the should as a must, right? So you cannot have twice the same key. All right. Then that's an example. That's actually JSON as data. It's a data set, just one object out of 16 million, I think, in total. That's a great language game that was online a few years ago. Now I think they put it offline, but it used to play an audio to you and give you a multiple choice, asking you what language is that? Is it Chinese? Is it German? Is it Italian? Or is it English? And then people guessed something on a certain date, and they actually collected all the data of the people playing the game. They call it the confusion data set, how people confuse languages. And now it's there to be analyzed. 16 million of them, it's a few gigabytes. And actually, it's a perfect data set to play around in this course that we will actually be using, that you can download. Because it's small enough that it fits on your laptop, simple enough, to understand. Here, there's just a nested array. It doesn't go very far. And it's also the kind of data set, as we will see later, that is relatively well structured in the sense that all of the objects look the same. So we'll see later that we can add schemas on top. All right, so this is just an example of the JSON as data that you could get. Note that wouldn't go well into a CSV file because of the nested array. If you want to put that in a CSV file, you need to hit it with a hammer. And if you hit it hard enough, then the array will be serialized as a string that goes in a cell of the CSV file. But of course, you're just shifting the burden to whoever opens the CSV file to then deal with it, because they will need to parse the array out of a string, right? So technically, that wouldn't fit in CSV because CSV is flat. All right, so now this is just one object and out of a collection of 16 millions. Now on another example, just to show you the relationship between a relational table and a collection of JSON objects. Here, what I want to show you is that a relational table is a special case of collection of trees. It's a special case of collection of JSON objects. It's a special case for two reasons. First, it's flat because you don't have any arrays or object nested in there. The only object you have is the outer object. And second, it's homogeneous because all of the objects have exactly the same keys. And on top of that, they have the same kind of values, right? Product is a string, price is a number, and so on. So this is why tables are a special case of that. And JSON extends what tables can do because it allows for nestedness and heterogeneity. For whom does that make sense? Right? This is very important because this is how we move on to denormalized data, right? So that's why tables are a special case. And now, if we are not even in first normal form, so that's no longer a relational table because it breaks the first normal form, but you see that JSON can do it. You can have in JSON this order that is the column that has nested tables. How do you implement a nested table? Just as an array of objects, right? So here we have an array of 3 objects, and that's our nested table, and you can convince yourself that this is pretty much the same thing. And again, in that case, it's relatively well behaved because the 3 objects look the same, right? It doesn't have to be the case always, but in that case, we have something that is nested and homogeneous, right? And so this is what you get. All right. Any questions on JSON? Okay. Now, a final word on JSON. JSON tends to be slightly more lenient than XML in the sense that the libraries will kind of be nice to you if there are a few mistakes. In particular, if you have unquoted keys in a JSON file, normally you shouldn't, that's not supposed to happen, but there are a lot of libraries that will not throw an error and just treat it as a string. Even if it's an integer, they will just add the quotes silently. So do not be surprised if that happens. The general rule is actually pretty simple. If you create JSON, always respect strictly the rules. Always quote your keys and no duplicate keys and so on. If you read JSON, then you can be more lenient and accept unquoted keys and fix a few things here and there. However, the exception is you're not supposed to accept duplicate keys because really that can really lead to a lot of problems because it's no longer a map, right? But that's basically the idea. If you create JSON, always make sure the quotes are there around the keys. If you read it, then it's fine to be lenient. Okay. However, XML is a totally different story, and it's actually well known for being extremely strict in the way that if there's a mistake, it's just rejected, which technically sounds like a bad thing, but it's actually a good thing because you're sure that you produce quality documents that parse according to the rules, and there are no surprises when you actually read them, right? So now I'm going to go through XML and explain it to you. Before I do that, I would like to say that from a data modeling perspective, in terms of denormalized data, XML and JSON is really the same. I really don't care which one we really use, right? There's pros and cons depending on the use cases, but I would really like you to, if you had, maybe you came with some preference that, oh, I don't like XML, it's so complicated, I prefer JSON, or maybe the opposite, right? I love the complexity of XML. I really would like you to take a step back and realize that XML and JSON are really just syntaxes for trees. That's it, from a data modeling perspective. XML has a few use cases that are not covered by JSON, but I'll come back on that, mostly from the publishing industry. All right, that's an example of XML, and this is just to show you because it feels, some people feel like, you know, JSON is the new format that everybody uses, and XML is actually disappearing. This might be true in academia in the sense that 15 years ago, everybody was writing papers on XML in conferences, and now nobody does anymore. But it's pretty much because we've pretty much explored everything there was to explore about XML. But in companies, in governments, this is a totally different story. And here, XML is extremely popular. And here, this is an example from the tax offices, the tax administration in Switzerland, where they have these e-government standards. And what you might not know is that when you submit your tax return, it actually internally is stored as XML like this. And the same goes, some of the banks can issue statements now with QR codes that can be opened by the online application of the tax office. And this QR code contains, guess what? XML. Basically the data as XML. So this is what you find in the, that's an example, a sample from the actual government standard that you can find here. As you probably noticed, they have some good sense of humor, which is actually great. All right. XML has a few building blocks just like JSON, and I'm going to drive you through them. Yes? I would say it's less enterprise ready than XML. And the reason is simply that XML has a much more older and mature ecosystem. It has a lot of tools, schema validations, query languages, and so on that are really mature. So the enterprises, the companies can really go in there. They know that they will have full support. And that's the reason actually why XML is chosen. JSON, even though technically, if you really dig into archaeology, it existed before XML, but it wasn't popular back then. And the idea is that all of the tools for JSON, they are now slowly appearing, but we are not there yet. We are not as far with JSON as we are with XML. Part of it is actually for the wrong reasons, is that there was these misconceptions about XML, that it's too complicated, and there was this temptation to throw everything away and just start over with JSON as a simple thing. Like, oh, we don't need schemas, we don't need query language, we don't need navigation, and so on. Only to realize a few years later that after all, we do need schemas, we do need query languages, we do need navigations, and now it's basically being added to the stack. But the good news is that we can learn a lot from XML because a lot of the tooling that has been developed from XML can directly, the ideas of that can be reused for JSON, right? So I'll try to give you this intuition. We'll look at schemas both for XML and JSON. There are query languages both for XML and JSON, and they're in fact very similar. All right, did I answer your question? Yeah. It's a different data model, so I'll explain it now. The data model, it is a bit more powerful than JSON in the sense that the specification is much longer and it has much more bells and whistles. but you don't need to know them all. Actually, I'm just going to teach you a few of them that cover 95% of the use cases, right? So we won't do all of XML, just the interesting part. And I'll give you an intuition why we can repeat elements. For example, in XML, I'll explain how it maps to JSON and nested tables, right? Because there is a reason for that. And yeah, so I'll have basically today and next week, I will explain all of that, right? Okay. Now, if you want to troll an internet forum or maybe Reddit, just ask, is JSON simpler than XML, and observe the avalanche of answers. This is actually pretty fun when it happens. Almost every couple of months, it actually happens. All right, I'm not saying you should do it, of course, just leave people alone, but you know, you might just observe that. All right. Note that I didn't say JSON is not enterprise ready. I just said it's slightly less enterprise ready in the sense that the tooling is basically ongoing, but it's making a lot of progress, right? And there are a lot of reasons why JSON is actually good. And I will also explain that in the context of data frames, that JSON actually maps quite well to data frames. So my goal is to give you the intuitions about all of that so that in your projects in the future, you can make enlightened choices, right? And I'm not saying one is better than the other. It really depends on your use case. All right, so XML has building blocks, just like JSON. The first building block of XML are these elements. And XML is actually quite famous for these angle brackets, right? Because it opens like this and closes like that. So these are called tags in XML. And this, in that case, is an opening tag. It's like a region that starts here, and then you have plenty of nested XML there, and then you close it because there's the slash here. It's like when you, in many countries, when you leave a city, you have this, you know, this line that crosses the name. So think of it like this: you're leaving the city full kind of here, right? So the slash. And then, because we're computer scientists and we're a bit lazy, in the case that this is empty, we don't want to have the opening and closing tag. So we just have this empty tag that is a shortcut with the bar at the end, and it's just a shortcut for this, really, right? You might know XML from HTML because HTML is really close in spirit, but HTML is much more permissive than XML. There are a lot of things that you can do in HTML that are not allowed in XML. In fact, there's been a huge debate on that in the standardization committees, because there was the hope at some point that with HTML5, that it would go in the direction of being stricter in the parsing of the syntax, just because to ensure quality. But somehow the sides who defended that we should be stricter kind of lost the battle. But there is still a compromise, because now we have two syntaxes of HTML. There's the HTML, the original one, and XHTML, which is an XML, kind of an XML version. All right, so these are the elements. The second building block is called an attribute, and it appears inside an opening tag or an empty tag. And you recognize it because of this equal sign. You have an attribute equals some string that has to be quoted. That's unlike HTML, right? In XML, it has to be quoted, double or single quoted. So this is an attribute. You can have plenty of attributes, and it's like in JSON objects, you cannot repeat the same attribute name in the same tag, right? So it's technically a key value model, the attributes and their values within one tag. Then we have text. Text is just free floating, just like that, between tags. And in fact, that shows you that XML was really almost having some, how can I put it? It was very, very popular in the publishing industry, and even the ancestor SGML. Because in XML, you can store scientific papers, articles, you know, journals, and so on. And so this is why it's quite popular in the publishing industry, right? A lot of the scientific papers that we publish are actually stored or published like this, right? So I cannot really say much about that, except that it's just text. And there are no quotes around it, because again, that's just floating. And then the tags are there to identify some portions of the text. And this is something JSON cannot do. So in XML, you can really have, let's say, 10,000 words, and then you have tags here and there that annotate the text. This is one of the things that JSON cannot do, all right? Now there are these comments, and please don't ask me why it looks like that. This is really inherited from the ancestor SGML, but the comments has this exclamation mark dash dash, and it ends with dash dash as well. And dash dash is not allowed in the middle of the comments just because that would confuse the parser, right? So this is a comment, but it's not like a comment in Java or C++. A comment in Java or C++ is just ignored by the compiler, right? Or by the application that parses it, maybe with the exception of writing documentation, but that's about it. In XML, the comments are part of the data model. It means that when you parse an XML file, the comments will be visible and passed over to the consuming application that uses the XML library. All right, so this is actually element, attributes, text, and comments is the only building blocks that we'll cover because I don't want to confuse you with the others. So don't worry about that. There's also processing instructions, but this is all I want you to actually learn. And this, I don't really call it a building element because that's just the header that you find on the first line of an XML file that basically informs you that this is XML, this is version 1.0, and this is UTF-8, the encoding. It's optional, you don't always have it, but if you see it, then you will know that that's just some text declaration. It's called, I have no idea why it's called text declaration, but that's how it's called. All right. Just so you know, there's two versions of XML, 1.0, 1.1. There's not a big difference. This is why a lot of people still use 1.0. 1.1 just addressed a few, like made it slightly more lenient with international alphabets and accepting Unicode characters. But you will see both versions. For the purpose of the course, you're not expected to really know the difference between the two. I don't expect that. So you can do as if there were only one version. And the encoding, if you create files, I recommend UTF-8, but you might in the wild find some XML files with different encodings. All right, now, just like I did for JSON, a few words on the well-formedness. This here is well-formed. In fact, that's almost the smallest document you can have. The really, really smallest would be just a single tag with no text declaration and with a name that just has one letter, if you really want the smallest one. But this is already pretty small. What's important is that at the top level of an XML file, you have to have exactly one element. Exactly one element. So here, that's the case. We have one element, foo. It's empty. There is nothing in there because I wanted something short. And that's about it, right? So it's well-formed. This is also well-formed because I told you this text declaration is actually optional. And again, if you remove the double O and just F, you have the smallest ever XML documents that you can have. This is not okay. This is not okay because here I have two top-level elements. I have foo followed by bar, right? Because they are two auto-closing. So they are empty element tags because the slash is at the end. So I have an empty element foo followed by an empty element bar. That's not okay. I cannot have two of them. It has to be exactly one, not zero, not two, exactly one. This is fine because here I do have exactly one top-level element, foo, and bar in that case is nested inside foo. It's its child, right? So I have really here the opening tag of element foo, the closing tag of element foo. So this is element foo. And inside of it, there is this element bar that is empty because of the slash here. For whom does that make sense? Right? So this is well-formed. This is not well-formed. Why? Because I have text on the top level that's also not allowed. Is that comments are okay. You can have top-level comments in the wild, that's fine, but you cannot have text, you cannot have additional tags of any kind, right? This here is fine. The text, you can have it inside the tag, but just not completely outside in the wild. Okay? So this is well-formed, and you see here that you cannot do in JSON. You have some text with some tag in the middle that says bar, right? It could be in HTML, if you have XHTML, for example, a BR, right? That is just a new line in the middle of the text. That's just an example. Or HR for a horizontal line. This is not okay because I can nest the elements, but when I nest the element, it must be between the tags, not inside the tags. So having another element inside the opening tag is absolutely not okay, right? So you see what's going on here. This is forbidden. I cannot do that. This is not okay, right? It has to be between the tags. This is also not okay because here I have an element inside an attribute, and I can also not do that, right? Because of this, it's the angle bracket basically that would confuse the parser. So this is not well formed for this reason, right? This is well formed. I just removed the angle brackets, and now I have a well-formed document. So I have, in that case, a top-level element foo with one attribute element. I could also have more, and then I have the nested bar element. It could also have attributes, right? Can I escape? Yes, you can, and I have slides for that. That will come shortly. Yeah, very good question. Okay. All right, and this is just also FYI, just so you're not confused. You might see this exclamation mark doc type. Who already saw it? Maybe in HTML? Some of you, right? This is really some inherited thing from the good old times of what was called DTD validation, but we won't cover them in that course. We'll use XML schema instead. But if you see doc type document, it's just a declaration that you have an XML document and its top level element is called document. Now you could ask me, why do we need to say that? It's obvious that there is a top level element called document, right? So it's kind of redundant that you also repeat it, right? But you might see this, and especially in the context of HTML, where you have this doc type HTML followed by the HTML tag. Okay, but it has to match. What you have after doc type has to be exactly the name of the top level element. Otherwise, that's an error. And technically, you could have inside the doc type more stuff, but I'm not going to cover it in this course. So you can forget it, right? Okay. Now, to summarize, what can appear where? Oh, we have a question on Zoom. So I don't think you can have nested attributes, right? Do you imagine an attribute inside an attribute? Like bar. Oh, are you saying that we could have this attribute element as an element instead of an attribute? Is it what you're asking? Yeah. So this is also how you can troll Reddit. Ask, should I use an element or an attribute? And then you will see how the discussion is going to just get out of control. The thing is that you can use both, and it really depends on the use case. If you want to mimic relational tables, I recommend using nested elements. That's what's done commonly. The attributes are usually for more metadata-like things, like an ID or something, right? That you might see them, or specifying a language, that sort of things. But the main difference, above all, the main objective difference, is that elements can nest. So if you use elements, you can create elements in elements in elements in elements. So this is how you get denormalized data, right? With nested structures and nested tables. We'll see how we can create nested tables. Attributes cannot nest, right? So if you use attributes, you're going to be stuck to something flat in any case, right? That's the main thing. If you want to nest, then you'll have to use elements. Does it make sense? Okay. All right. Okay. So now, just to summarize, the elements, there has to be exactly one element, so just once on the top level. Between element tags, as many as you want, you can even repeat the names. There can be duplicates. But inside an opening element tag, no. It has to be between the element tags. Attributes can only appear inside an opening element tag. And when I say opening, that includes the empty tag, of course, as well. So it cannot be in the closing tag, for example. It can be only in the opening element tag. It cannot be top level. It cannot be between element tags. Well, technically, you could write attribute equals blah, blah, blah between element tags, but that will just be text. It's not going to be interpreted as an attribute. And text is between element tags. If it's inside an attribute, that's not text. It's just an attribute value, right? Now we have another question with XPath.
I think in terms of XPath, when you want to search the document, an attribute is a tag as any other name tag. It just has the same name, while attribute value will be a different lookup option.
Yes, so let me say a few words. We will cover querying a bit later. in this lecture, so it's really just a parenthesis. XPath is a language that allows you to navigate HTML. We will see we can also do it with JSON. And when you navigate, you can navigate to specific elements and attributes. And in the syntax, the way you differentiate them is that you have a small arrow-based character in front of the attribute name to mean that you mean an attribute. And if there is no @ then it's an element. Right. Is it what you had in mind on Zoom? Just continue. So, all right, but I'm closing the parenthesis. You don't need to worry about XPath just yet, right? Right now, the only thing we care about today is whether a document is well-formed or not. It's a yes/no thing, right? Yeah, thank you for that. Thank you for clarifying. It's very good that there is interaction. All right. Now, why is this not well-formed on the top? Because there is twice exactly the same key. And you use the word key, it makes a lot of sense. You could see it as a key. So there is indeed twice the same attribute foo, right? And if you think of it as a key, then that's not okay. You cannot have duplicates. This is strictly forbidden. You will not find a single library that would accept that. The second one is fine because there are two different attribute names here. This is not well-formed, the first one, and here it's a bit like well-parenthesized expressions. That's that sort of thing, is that if you nest B inside A, then you have to close B before you close A, right? If it's properly nested. Do you agree that the first one is not properly nested? Right? They are intertwined, so that's not okay. Okay, now the question, can we escape characters? The answer is absolutely yes, we can escape characters. But it's not going to be done with a backslash. You might have anticipated something like JSON with a backslash. When in XML, we use this ampersand character, this thing right here, right? And then a semicolon, and LT means lower than, right? And this is forbidden. You cannot have, this would confuse the parser. It would make the life too difficult. So this is not okay, but you can escape it in this way in the memory that will be interpreted as this, right? And there are 5 of them. It's easy, just these 5, so learn them by heart. There's LT, GT, greater than, the apostrophe, the quote, and the ampersand, that if you want to actually have an ampersand, that doesn't mean an escape sequence, right? It's like the backslash in JSON. You need to learn that by heart. There are only these 5. You might know a few from HTML, like ampersand, NBSP, semicolon for spaces. That doesn't exist in XML. There's nothing like that. There is nothing beyond these 5. You can define more, but I'm not going to include that in the material of the course. Okay, all good? I have a story on the ampersand. You know that, why is it called ampersand? So the English alphabet today has 26 letters, but it had more before. It had a few letters that now you find in Icelandic, for example. They have not disappeared in Icelandic, but we don't see them anymore in English, like the sound had a specific letter. And ampersand was also one of these letters. Now, it was called and, because the semantic of that is and, A-N-D. It was at the end of the alphabet after the letter Z, right? And at some point, all of the other letters disappeared, and only the ampersand in addition to the 26 letters remains. So now you have to imagine at school when the kids are learning the alphabet, they go like A, B, C, blah, 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 X, W, Y, Z. W, X, Y, Z, sorry. And then they would go like W, X, Y, Z, and that sounds strange, right? So they needed to find a trick that made it sound like, I don't know, it's like a lullaby kind of thing or something that sounds nice to the kids. And so they made it like W, X, Y, Z, and per se, and. It means and by itself, and. So and per se, and. And of course, when they started saying it by heart, right, very quickly, W, X, Y, Z, ampersand, ampersand. That's how it emerged. So this is the reason why it's called ampersand. And you will find all textbooks from the 19th century where you will see these alphabets, right? All right, end of the parenthesis. There is a question.
Don't use UTF-8 as encoding because of some legacy software. Would I have to escape, e.g., umlauts.
Yes, absolutely. And there is a way to escape. Do I have this? No, I don't have it. You can also escape. I should add it maybe for next time. There is a way to escape character sequences with the Unicode number, just like in JSON with the \u. So it's technically an ampersand followed by a sharp. And then you have the decimal, the base 10 code followed by a semicolon. So the answer is yes, you can. So if you are using ASCII, you can do it. Right. It cannot be this, what you're writing, it cannot be. Yeah, that wouldn't work. You really would have to write ampersand, sharp, and then the number in the Unicode catalog of the letter that you want. Actual digits, you would have to do this. Right. Okay? Defining AUML in the way you umlaut, you could do it, but it's not part of the course material. So this is why you don't have to, you should consider that it doesn't exist. Okay? All right. Now, obviously, you cannot have quotes in quotes. So in CSV, you would double the quotes. But in XML, what we do instead is that we use the escape sequence for the quote, which is the ampersand quote semicolon. And now we can do that. The same for, I said, the angle brackets you cannot have. You have to escape it as ampersand LT semicolon, right? Now, this is the overview of the escaping. What to escape where? Of course, you can escape anything anywhere, right? It will not complain, but sometimes you're obligated to escape. So if you are in the text, you must escape the lower than and the ampersand. If you are in an attribute value that is double quoted, then you must escape the double quote as well as lower than and ampersand. If you are in an attribute value that's single quoted, you see an example right here, that's totally okay, then you must escape the single quote lower than and ampersand. So this is a sample document that is totally well-formed that shows you, what you can do. And here, this is a load, this is a load, this is a load, this is a load, this is a load. Here, you had to basically escape this, right? Okay. By the way, there is a piece of software that you should download because ETH purchased it for us. I really begged them, and they kindly accepted it. It's very expensive. It's a site license. Everybody can have it. So go to the ETH IT shop, look for Oxygen, and download it. It's a really nice editor that you can use to learn XML, JSON, and so on. You can put it in there. It will show you the errors if you want to look for well-formedness. But it also supports data validation with XML schema, with JSON schema. It supports JSON line files in a newer version and so on. So it's really very, very convenient also for your projects later if you have to deal with that kind of data. Okay, I think that I'm going to wrap up for today, just making sure that you followed what I've been telling you before I let you go. So of course, I imagine that this will not work exactly. So I need to click again. And now it seems to be working. It's incredible. Today, everything worked. The network worked, the microphones worked, the clicker apps are working. Okay. Everything, more than 80%. Oh, this is really, really, really good. Yeah, okay.
How was the editor called?
Oxygen, like in the air, what we breathe. OXYGEN. Okay, this is awesome. And a lot of you even understood everything. So that's great. Again, don't forget what I want you to see within 2 weeks. I want you to see trees, and we'll actually be drawing trees in 2 weeks from now. Thank you very much. I hope you enjoyed today's lecture, enjoyed the exercise session on HDFS. Don't forget the JSONic tutorial. There was none last week, so I kind of merged them into one. So do not forget to look at the JSONic tutorial of the week. And yes, so I will let you in the capable hands of the TAs for the exercise sessions, and I'll see you next Tuesday at 2 p.m. Thank you very much.